Anything you like to pick? Anything from 1 through 62. Indefinite, definite. Anything. Any preference?
Is it possible we can do one indefinite and one definite?
Yes, please choose anything you want.
Number 26.
Yes, 26. Very good. So in 26, we have the integral from t squared minus 1 to the 5th power dt. Perfect. And let's also choose the other one so I can, the definite as well. I'm going to write it on the side.
Number 58.
58 is fine. So that's the integral from 0 to 4 for x from x minus 6 squared dx. Perfect. Good. So let's start with the indefinite. Can anyone give us an idea on what would you use as a substitution? Any suggestion?
T squared minus 1 would be u.
Yes, perfect. Now we need du. Awesome.
2t.
Thank you very good. Awesome. So we do have the t, we do have the dt, we don't have the 2. That's a piece of cake. Multiplying by 2 and dividing by 2 never changed anything. So now let's change everything from t to u. 1/2 has to stay. What do we replace t squared minus 1 to the 5th power by?
U to the 5th.
Very good. What do we replace 2t dt by?
dut.
D.
Oh, du, sorry.
Perfect, indeed. So this is 1/2. Now we know how to address this is u to the 6th over 6. Do not forget the constant c. It's an indefinite integral. It's the most general antiderivative, right? Multiply these two. So we get 1 over 12. Put parentheses because we have to go back to the notation. It's required for indefinite integrals. So we have t squared minus 1 to power 6 plus a constant c. And this is done. Very good. Awesome. Thank you. It makes me very proud when students contribute, even if you're wrong. Very proud. Okay, so let's go back to this one. Any questions here, first of all?
No, thank you. That was good.
Perfect. Now let's continue with this one. Can anyone give us an idea of a substitution? You can use any letter. If you prefer u, u is fine.
Would be x minus 6.
Absolutely. X minus 6. Now let's determine du.
D of u, or d x.
Exactly. So it happens that du equals dx. That's fine. So then this will be replaced by du. What do I replace this by?
Don't you have to find your new values?
Yes. Yes, absolutely. Yes. You want to start with that? That's fine too. I was going to say, do not copy the limits of integration. You're way ahead of me. I love it. When x is 0, u is?
-6.
Perfect. When x is 4, u is?
-2.
Perfect. So now what do I replace x minus 6 squared, quantity squared by?
U du. Oh, u squared du.
Very good. So this is u to the 3rd over 3. We do not go back. There is no need to go back. We have new limits of integration. please keep 1/3 outside. Remember how to read this. It's 1/3 u cubed. That will simplify the numbers and the calculations a lot. Plug in -2. -2 to the third is -8. Minus, when I plug in -6, and I still get a negative number. So 6 to the third. Okay? Divided by 3. So, lazy, lazy, lazy. So I have -8 plus 6 to the third. I got 208 divided by 3. This you can check. The previous one you can also by differentiation. So if you want to check, you can. Let me clear all this. So we have the integral from 0 to 6. And we have x minus 6 squared. New set of parentheses. Be very careful how you enter this. And dx. And when I click enter, I have to get 208 divided by 3. Oh, I didn't, yep, uh-oh. Uh-oh, 208 divided by 3 is not 72. Oh, it was, yeah, I got it. It was 4, not 6. So the answer has to be 208 divided by 3. And if it's not 208 divided by 3, I have to go back to the drawing board. Any questions on indefinite or definite? Again, this is called definite. It's carved in stone. Definitely between this and this. This is free. Any function whose derivative is t times t squared minus 1 to the 5th power will work. This is free. This is carved in stone. It's one number and one number only. Good, excellent. Where's my page? What did I do? Okay, here it is. Anything else? So this is basically definite and indefinite and also substitution. We did both. Antiderivatives, it's exactly what we've just been doing. This is the antiderivative of that. Consumer surplus, producer surplus, differential equations. And this is what we did last time. And we did one max min. So we still have time, 20 minutes. Let's make you, yes, I'm ready.
We do a differential equation.
Yes. So let's take a look at differential equation. Very good. This is in section 5.7. I'm looking at the page number 5.7, 535. Five 36. The same thing, they're all the same, they're just throwing different notations at us. Instead of dy over dx, they say, oh, why don't we use dg over dt? Instead of dy over dx, oh, why don't we use dt over dt? Or dp over dt, they're all the same. So 26 through 42. Anything you'd like to pick. And I'm on page 7.
Can we do 33?
Yes, 33. I hope we didn't do it before. 33. Perfect. 3y squared. So you have as many examples as possible. dy over dx equals 5x. Did I copy from 2 problems? Sometimes I do. No, I think I'm okay. 3y squared dy over dx equals 5x. Excellent. Good. What will be the first step here? What do we need to do first? By simply looking and inspecting this.
So what? Do we set y to one side and x to the other side?
Yes,
So multiply 5x by dx.
that's it. We multiply both sides by dx. 3y squared dy equals 5x dx. Yay! What is the next step? They are completely separated. Done. What now? In the next step, we have to,
Differentiate.
you mean integrate. Good? The left-hand side, which function prime is this?
Y to the third. Oh, over 3.
That's it. Perfect. 5. Which function prime is x?
5x squared over 2.
Very good. And we only add one c. Why? We should have c on both sides, but we can combine the c's into one and put the c on one side. So we have y cubed equals 5 halves x squared plus c. This is algebra now. How do I get y? What do I have to apply to both sides, like I applied here? Sorry about that. I forgot to turn on my phone. It's off now. Sorry about that. So like here, we integrated both sides. Here I have to do what to both sides to determine y by itself.
Finding cube root.
That's it. Cube root here and cube root here. Awesome. Excellent. That's it. And that's the final answer. Perfect. Well done. Where is my page? Anything else?
Can we do
Yes.
the domain question?
Yes.
6 after 6?
Yes. Very good. Awesome.
Actually, if you don't mind, can we look at the one for the homework?
Yes. I'm ready. I don't remember what it is.
Just 1 second. It is. Determine the domain of g x comma y equals 1 over y plus x squared.
That's it?
Yep.
Perfect. So, what is the only condition we have to state here? That the...
Denominator cannot equal 0.
That's it. There's nothing else. So I write the domain for this function is any ordered pair that has the property such as y plus x squared is never 0. That's it.
Thank you.
That's it. Thank you. Good. Other questions? We can still go back to what I checked, of course, if you think that we should look at more examples.
Can we do partial derivatives?
Absolutely. So this is in section 6.2. So let's take a look at 6.2. 6.2 with 6.2 is page 567. Find fx and fy, or find all first and second order. I can find second order before I find first order, of course. And I remember we worked on one example from here. This is just a different notation. It's in preparation for a section that we do not cover. It's about, so when you see this symbol, it's a Greek symbol, lambda. Where did I see that? Here. It's a Greek symbol, lambda. And as you see, Greek letter, lambda. And it deals with, it's section 6.5, which we do not cover in this class, about Lagrange multipliers. So it's another variable for, in this case. So we have three variables. Instead of using x, y, and z, they used x, y, and lambda. So let's choose anything you want.
We do a tolerance for a problem.
The tolerance.
Yes, ma'am.
So these are not part of the class. We haven't talked about something like this. Did you encounter a problem like this on the in Pearson? If you did, I have to remove it. But I doubt you did.
No, ma'am.
Okay, good, good. So we want to choose, or I will.
You pick one.
Okay. I will pick. What about 35? Something different. Okay, on page 8. So number 35. You can choose the next one if you like, if this is not good enough. xy equals x natural log y. And they want us to determine everything. In other words, all 6. Good. So first we start with fx. We differentiate this with respect to x only.
Would it just be
Would it be you?
Natural log y, of course. It's a constant times x. When I differentiate, x prime is 1, the constant stays. Good. Now I want to find fxx, since I'm here. We want to differentiate this with respect to x.
0.
Excellent. We want to differentiate now with respect to y only.
Just x.
What is the derivative of natural log?
Oh, 1 over y.
Yes, so it will be x over y. Excellent. I want to differentiate this with respect to y. Again, I have to be careful. I recommend changing this into x times y to -1. Because it may get confusing if you use the quotient rule. So we're differentiating this only with respect to y.
-x?
Times we have to subtract 1 from the power.
-2.
That's it. Good. Now we want fxy. We differentiate this. It's already with respect to x. Now we want to differentiate with respect to y only. That's it. You mean 1 over y. Good. So now the only other thing that we need to determine is fyx. It's already differentiated with respect to y. We want to differentiate it with respect to x. Remember, we need to see this in this form. If we don't see it in this form, we may have difficulties in finding the answer. I need to differentiate this with respect to x only.
Just 1 over y.
That's it. They have to equal each other. If they don't, we are in trouble. Very good. I lost my page again. No, I found it.